Hello my dear students, I welcome you to NEET World. So in this session, we will be focusing on all the important Nemer reactions. So here, I have covered all the important Nemer reactions in this session. See, if you are going to attempt the exam very soon, I mean if you are having very less time, for example tomorrow you will be having a NEET exam, right? So for you, you just watch for the first 20 minutes, that will be very helpful, okay? So because within the first 20 minutes, I will be only giving you some some clarity on all the important reactions. So after that I will be covering some important, like main important reactions with more clarity, okay? So here let's start. So I have covered the Nemer reactions from all the chapters of organic chemistry here. So first thing is here halogenation and substitution. So here we will be studying these Nemer reactions in haloalkanes, haloarenes chapter, right? So let us look here. So here we have this Sandmeyer reaction, Gattermann reaction, Finkelstein, Schwarz, next Riemer-Tiemer and Kolbe's electrolysis. So these are the reactions we have. So let us understand them one by one here. Okay, so just give me whether everything is clear, my voice and everything. Just I want to check here. Yes. Look here. So Sandmeyer reaction. So all these things. So first three reactions you can, first two reactions you can see, 1 and 2. So both of them are having diazonium salt with copper halide. So it will be copper halide and copper halide will give aryl halide. So let us look here. So what we required here, so they are saying diazonium salt, okay. So this is our diazonium salt, okay. I am covering first two reactions here, okay. So this is our diazonium chloride, okay. So when we are treating these with the CUX, copper halide, for example X, let us say Cl. So Cl, so copper chloride. So this diazonium chloride, so just remove this N2 gas from here and replace that with Cl minus. Okay, like this. Okay, I hope this is clear, right? So this reaction is what? A Sandmeyer reaction. Okay, then next we have Gattermann reaction. So here what happens, same Sandmeyer, same diazonium chloride here, when we are treating this with copper metal with acid like HCl and HCN. So this will be giving aryl halides here. Okay, so just write aryl aldehyde I have written. Okay, so then next here we have, again we have one more Gattermann-Koch reaction, that will be different, we will be discussing about that later. So now look here, Finkelstein-Schwarz reaction. So these two follows what? See here, diazonium chloride is removed out, I mean nitrogen is removed from here and they are replaced with Cl minus here, right? So which means, which mechanism here it is following? See, one nucleophile is going out and one nucleophile is coming inside. So can I say nucleophilic substitution reaction? Yes, the mechanism followed in these reactions, the first two reactions is nucleophilic substitution reaction, okay. You should be clear with the mechanism also. So now how can we prepare this? So we will be preparing this, with aniline. So what is the starting material? We will be taking aniline and we will be treating this with NaNO2, HCl, okay. So like this they will give, otherwise HNO2 directly they will give and 0 to 5 degrees temperature they will mention, okay. So this is what the thing they will be mentioning here, you should understand that, okay. Instead of giving like this, so they will be directly giving in this format. See, aniline, they will mention this and here they will write some A reagent will be, some X reagent will be used, therefore it is giving A product, okay. So A product upon treating with CuCl will be giving us this thing. So what is X and A? Identify from the following options. Like this they will be also mentioning and asking about the intermediate and the reagents used in this particular conversion. So this kind of questions we may expect in the exam, okay. I hope this is clear, first two reactions. Then next we have Finkelstein reaction and Schwarz reaction. So what exactly Finkelstein and Schwarz, let us see, okay. See here, so just stay with some patience. So we will be discussing everything clearly, wait for some time, okay. I hope first two reactions are clear, right? Okay, let us discuss about Finkelstein and Schwarz reaction here, Okay, so here these reactions are preparation for halides. Okay, so when I am saying halides, okay, so when I am saying halides, see, we will be using alkyl chlorides or alkyl bromides. Okay, and when I am saying Fink-Liston reaction, so this Fink-Liston reaction is used for Fink-Liston is used for preparation of alkyl iodides. For what? Alkyl iodides. So for this purpose, in this reaction we will be using sodium iodide like this. Okay, now the mechanism followed here is SN2 mechanism. What is that? SN2 mechanism, because here I have taken primary alkyl halides giving the product. So mechanism is SN2 here. So the acetone is a like solvent. So what is a solvent? Generally we will take acetone as a solvent here. I hope this is also clear. So what is the name of this reaction? It is Fink-Liston reaction. Then next we have Schwarz reaction. So what is a Schwarz reaction? So whenever I am saying Schwarz reaction, so this is for preparation of alkyl fluorides. So RF will be prepared in this reaction. So here we will be using inorganic salts like AgF, something like this, AgF2. Okay, so here AgF2 is SbF3, like this we will be using in the Schwarz reaction. So what is the product? See, reactants are also halides, products are also alkyl halides. Okay, so what do you getting from this? So what you need to understand from this? Here it is the alkyl fluoride, alkyl iodide is formed. So halides only giving again halides. So can we say halogen exchange reactions? Yes. See, one halogen is exchanged by the other halogen, right? So can I say like halogen exchange reaction? So they may ask like this, from the given 4 options, which are the reactions considered to be halogen exchange reactions? So one is Schwarz reaction, another one is Fink-Liston reaction. In Schwarz reaction what happens? Fluorides are formed. In Fink-Liston reaction iodides are formed. Okay, so there is no direct method of preparation for fluorides and iodides because of fluorine like halogenation, fluorination is very reactive. Therefore direct methods are not there. Therefore we will be using the halogen exchange reactions. Okay, and iodination is very slow process generally. That's why we are not preferring direct iodination of alkanes. So we are preferring the halogen exchange reaction. Okay, I hope this is also clear. Okay, then next Riemer-Tiemer and Kolbe. So we will be discussing about this 5 and 6 here. So you can write these 2 reactions here. So these 2 reactions. Okay, so in Riemer-Tiemer reaction and Kolbe reaction, in both of these we will be taking phenol. So what we are taking? Phenol. Okay, this phenol, see, let us discuss about Riemer-Tiemer reaction, one of the important reactions. So phenol with chloroform and NaOH. So here I am taking chloroform CHCl3 and basic medium in NaOH. This will be giving us the final product like this. Salicylaldehyde. What is the name of the product? Salicylaldehyde. Okay, this is ortho product now, orthosalicylaldehyde you can call. Okay, and we can also get a para product, that is para salicylaldehyde like this. Okay, so out of these 2 reaction 2 products, so this will be the major. So why it is major? Because of hydrogen bonding here. This is what? Hydrogen bonding between the hydroxy group hydrogen and the carbonyl group oxygen. I hope this is also clear. Okay, now what is the electrophile involved here? See, when this chloroform CHCl3 is reacting with NaOH, so these will be undergoing alpha elimination and producing dichlorocarbon. So what is this dichlorocarbon? Alpha elimination means from the same carbon this hydrogen and one chlorine is removed. Therefore what are the remaining parts? Here we have CCl2 will be the remaining part. So this will be called as carbene. So what is the electrophile involved in Riemer-Tiemer reaction? Carbene, dichlorocarbene is the electrophile. Okay, this is what you need to remember here. And the next thing is, so here why the reaction is taking place at this position? See why? Because we know phenoxide, like phenol, upon treating with this base NaOH. So what it will be forming? It will be forming a phenoxide ion like this, O minus, like this, right? Okay. So this phenoxide ion is strong electron releasing group, and increases the electron density at ortho positions and para position. So what exactly happens here? Look, see, when this negative charge is pushing downside, it means given into the ring, therefore the pi bonded electrons will move here and creates like this. So see, at ortho position we have negative charge, right? So it means here we need to add the electrophiles. So whenever we have electron releasing group on benzene ring, that creates negative charge at ortho and para position, therefore we will be getting ortho substitution and para substitution products. Okay, I hope like Riemann-Tiemann reaction is clear. Okay, then next let us discuss about this one, Wolff's process reaction. So here phenol with CO2 gas and NaOH, same phenol only in the basic medium NaOH, therefore first it will form phenoxide ion. To this we are taking the electrophile, that is what, CO2 gas, carbon dioxide, COO. So now the carbon is electrophilic center because oxygens are more electronegative, therefore they will drag this pi bonded electrons towards themselves and creates positive charge on the carbon, right? Okay. So due to this reason, what happens? The electron deficient site is carbon, right? On that the pi bonded electrons of this phenoxide ion will be given. Therefore we will be having a, if it is moving this side, we will be having like this. Okay, here we have one pi bond like this, and here we have one hydrogen. Now see here, I can remove this hydrogen from here like this, and we will be getting directly the product is this one. This will be the final product. So what is the name of this product? Here I am saying whenever we have aldehyde, I am saying orthosalicylaldehyde. Okay, now we should call this as salicylic acid. What is that? Salicylic acid. Again here also ortho product only major. See here also similar to the above reaction, Riemann-Tiemann reaction, we have two types of product, ortho and para. Out of this ortho product only major. Why? Because again due to intramolecular hydrogen bonding, which is a stabilizing factor in the ortho product, therefore it is considered to be major. Okay, I hope this is also clear. Okay, in coal base reaction, see, try to take a screenshot of these statements, therefore this will be very useful for like single line revision. By looking at the name and the single line of the single statement, that will give you some clarity on the reaction, right? That is enough for preparation. Okay, always remember when you are making your short notes, it should be very simple and very accurate. Okay, by looking at the name or by looking at the statement, you should get complete idea about that particular reaction or particular concept. Okay, now see phenol, CO2, NaOH. So undergo on coal base like coal base reaction gives salicylic acid as a product. Riemann-Tiemann reaction, so salicylaldehyde is formed. Here we are taking phenol plus chloroform in basic medium, that's it. Like this we should understand what is the intermediate involved or what is the electrophile involved in Riemann-Tiemann reaction. So it is dichlorocarbene, CCl2, that's it. Okay, like this. I hope all these 6 reactions are clear, right? Let's move further. So next we have elimination reactions. So what exactly here? Elimination reactions and addition reactions we will be seeing. Okay, now see, first of all let us study about this elimination reaction. Okay, so where do we seeing this elimination reactions? More generally we will be preparing alkenes using elimination reactions, right? So let us take like I am taking like alkyl halide here. Okay, alkyl halide I am taking, to this I am adding alcoholic KOH and heating condition I am taking. Okay, what happens here? So here they are saying sage of product, predict major alkene in the elimination reaction. So what is the sage of rule? So whenever we are whenever we are seeing an elimination reaction, so sage of rule says that the more stable alkene is majorly formed. So how can we decide major product and minor product? Based upon their stability, based upon the stability of alkene. So which alkenes are more stable? Internal alkenes are more stable than the terminal alkenes. It means double bond should be inside, not at the terminal of the chain, right? For example, here, see, by eliminating this halogen by using the beta proton, see, this is the alpha carbon, so this is the beta carbon, hydrogen present on the beta carbon will be beta hydrogen. So here we have, again here also 3 beta hydrogens are there because this is beta carbon, okay. Now using this strong base, I can eliminate proton from this position and from this position, okay, both possibilities are there. Therefore, when we are eliminating these two things, when we are eliminating this hydrogen and this proton and this chlorine, so we will be getting a product like this, right? This will be the product. So when we are eliminating this beta proton using the and this chlorine, so we will be having a product like this, okay. So these are the two possible products we can expect in this reaction. Now tell me, which alkene is internal and which is external, or which is terminal? See, this double bond is having both sides, more substitution is there, therefore I can say both sides alkyl groups are attached, therefore we can consider this as internal alkene, which is more stabilized by this alpha hydrogens by hyperconjugation, right? Okay, so it will be more stable alkene than this because this is at the terminal of the chain, therefore this is less stable than this because here hyperconjugation plays an important role for the stability of internal alkenes. Here less stable alkene, less because less number of alpha hydrogens are there to this alkene, right? I hope this is clear. Therefore, what he is saying, Sergev product. So Sergev rule says this will be the predicts a major alkene in the elimination. So according to the Sergev rule, that is internal alkenes are more stable and they will be formed as major. Therefore, this is major. Yes, I hope this is clear. Okay. Now here we have one more type of elimination, that is called Hoffmann elimination. I will be saying here itself, okay. So now here instead of taking this halogen, see I am okay, let us take this halogen and here I am taking one bulky base. So this is looking like tertiary butoxide. What is this? So this plus symbol is nothing but here carbon is there, here one CH3, CH3, CH3. So 3-4 carbons are there, we should say tertiary butoxide ion. What is this? Sodium tertiary butoxide ion, okay. Now whenever we have a bulky base like this, see this is a small strong base, but this is a very bulky base, right? So in this case also elimination reaction takes place, but where it is taking place, see, since it is very bulky, it is having more steric repulsions with these bulky groups, these methyl groups, therefore it will easily abstract a proton from the terminal side, and in that case this terminal alkene will be the major. So terminal alkene will be the major when we are having a bulky base or a weak leaving group, like instead of having chlorine, if we have fluorine here in this place, so that time Hoffmann product is major. This will be called as Hoffmann, this will be called as Sergev product. I hope this is clear. So this will be major, this will be major. When it is major, this will be major when we have a bulky base or a weak leaving group, okay. So this should be called as Hoffmann product. Okay, these are the two things you should remember. Next, Markovnikov rule, anti-Markovnikov rule. So this is what exactly? This everyone should know about this Hoffmann, Markovnikov and anti-Markovnikov rule reactions. See, I am taking the alkene like this. So let us first of all identify whether this is symmetrical or unsymmetrical alkene. See, when a double bonded carbons are there, this is the alkene, right? Okay, on this carbons, one side we have methyl group and here hydrogen, this side two methyl groups are there, right? Okay. Now if all the groups attached this side and this side are equal and same groups, then we can say symmetrical alkene. But here we have two methyl groups, here only one methyl and one hydrogen. So I can say this is unsymmetrical alkene. So to this I am adding HBr. So we are adding alkyl halide like HBr. Okay. Now we need to add H at one carbon and Br minus at another carbon, because this is a strong acid, H plus Br minus we have. Okay. So where do we need to add H plus and where do we need to add Br minus is a big question here. So how can we answer this? Look, so whenever we are adding this H plus ion, because H plus ion is an electrophile and this double bond is there now, so that will be acting as a nucleophile in the first step. It is following electrophilic addition reaction mechanism. Okay, so whenever we are adding this H plus to these double bonded carbons, we should get a more stable carbocation. Therefore, if I add H plus to this carbon by using these pi electrons, so carbocation will be here. Okay, this is one case. See, this carbocation if we generate here, that will be tertiary carbocation. In other case, if we add this H plus on this carbon, the carbocation will be generated on this carbon, which is secondary. But we know tertiary carbocation is more stable than the secondary carbocation. Therefore, we need to generate a more stable carbocation, that is what the tertiary carbocation here, but not here, right? Therefore, add H plus here and generate carbocation on this carbon. Okay. Now I am adding H plus. See, here we already have one hydrogen and one more new hydrogen is added, and here we are generating this carbocation. So this is tertiary carbocation, right? Now this, the remaining negative part Br minus will be added on this carbon. That's it. This will be the product. Okay. So on one carbon we have added bromine, other carbon we have added hydrogen. I hope this is clear. So both things are added to this complete reagent, it is added to the substrate. So what is the reaction? It is an addition reaction. So what kind of addition? It is electrophilic addition. Why electrophilic addition? In rate determining step or the slowest step in this reaction is addition of electrophile. Okay. Okay, I hope this is clear. Addition of this H plus ion here. Okay, that will be the rate determining step in this reaction. I hope it is very clear. Now what exactly Markovnikov rule, anti-Markovnikov rule? See, here on this carbon we have 0 hydrogen, but on this carbon we have 1 hydrogen, right? So Markovnikov rule says that the negative part, see HBr is there now, so I can write H plus Br minus. Okay, so the negative part of the adding molecule, this HBr is the adding molecule, the negative part of the adding molecule goes to the or added to the least number of hydrogen containing carbon atom of alkene. See, which carbon is having least number of hydrogen? Here it is 0 hydrogens, here on this carbon 1 hydrogen. So there is no hydrogens, I mean 0 hydrogen, which is the least number, right? There we need to add Br, yes, we added there only, and another one we added H plus on the other, that's it. So this will be the major product. So what is Markovnikov rule? The negative part of the adding molecule, that is what the addendum. So negative part of the addendum goes to the least number of hydrogen containing carbon atom in the alkenes. Okay, I hope this is clear. Now anti-Markovnikov rule means what? Whatever we studied till now, reverse of that. So what it is exactly? The negative part of the hydrogen, negative part of the adding molecule goes to the more number of hydrogen containing carbon. It means anti-Markovnikov rule product means you should write like this. So here H, here Br. So this will be the anti-Markovnikov rule product. Okay. So now my question is, when will be this formed, when will be this formed? See, whenever we have an unsymmetrical reagent like this, we are adding to the double bond like HBr, HCl like that. So directly add by following Markovnikov rule. Okay. So if along with this HBr, see along with this HBr, if we have H2O2, any peracid is present, then anti-Markovnikov rule product is major. Anti-Markovnikov rule product is major. So this will be the major. When it is major? When HBr is present along with the H2O2 or any peroxide, okay, any peroxy bond containing compound, then that case major product is anti-Markovnikov rule product. Okay. In all other cases, Markovnikov rule product will be the major. Okay, I hope this is clear. Okay. Then next, what are the other Nemer reactions I have mentioned here? See, one thing you should remember here, I am not just covering the Nemer reactions, I am covering all the important reactions that should be done whenever you are going to the exam. Before the exam you should look into those reactions first. Okay. So I have brought all the important reactions from each of these chapters. Okay. So don't worry, just follow the class. Next, hydroboration oxidation. So just take any alkene. So I am taking one alkene here. Already we covered this in the Where? In the hydrocarbon chapter. Okay, so take one unsymmetrical alkene. So this is alkene. So to this we are adding half B2H6. They will give like this, NaOH H2O2, like this they will mention. So this is also follows anti-Markovnikov rule addition. So what happens? Alkenes converting into alcohol. It means we need to convert that into alcohol. So what exactly happens here? Just look here. So to this we need to add one H and one OH. So where do we need to add? So whenever we are seeing this kind of reagent, follow anti-Markovnikov rule, product, a similar kind of product will be getting here. Okay, so it means negative part OH minus, the negative part should goes to the more number of hydrogen containing carbon. That is what the anti-Markovnikov rule. So here you write OH, here you write H. Okay, I hope this is clear. Okay, so if you want to know more about this, or if you want to get more clarity on hydrocarbon chapter, so there are 3 videos specifically made on the hydrocarbon chapter, includes mechanism, everything. So you can go and watch it after this session. Okay, so if you won't have any time, just this is enough for now. Okay, if you are having time, you can go. Next, oxidation and reduction reactions. Okay, so here what happens in Bayer's test? So alkenes, take alkenes again. Okay, let us take this alkene. Okay, so when we are adding this KMNO4, this is what? KMNO4, Bayer's reagent we can say. So dilute KMNO4 also they may give. Okay, so just remove the double bond and put OH here and OH here, that's it. So this is cis diol. What is this? Cis diol. Again, we know KMNO4 is having pink color, right? Violet or pink color. So that will be decolorized whenever we are adding to the alkenes. So what is the use of this test? So this test can be also used to identify the unsaturation. So this is what? Test for unsaturation. So they may ask you, giving 4 options, which are the following is suitable test for identifying unsaturation. So you can choose Bayer's reagent or Bayer's test. Okay, next, ozonolysis. Same, alkenes, whenever you are treating with ozone, zinc, okay, so you just break this bond and solve like this, they will be mentioning. So break this bond and write double bond O. Okay, so just break this bond and put oxygen this side and that side, this will be the product. So here we will be getting 2 moles of the same product. Okay, Clemmensen reduction. So what happens to the Clemmensen reduction here is, so whenever you have carbonyl compound, see carbonyl compound with zinc, see this is the carbonyl compound only now. Okay, so this whenever we are treating with ZnHg and in acidic medium HCl, so you just remove this C double bond O, okay, and replace it with the 2 hydrogens like this. Okay, it means for example I have benzaldehyde here or acetophenone I have. Okay, so upon Clemmensen reduction, so what happens? Okay, so just remove this part. It means remove that part, remove that oxygen and replace it with the hydrogens. Like this is the product. It means here 2 hydrogens are added. Okay, simple. Whenever you are seeing this one with this kind of reagent, convert that into the CH2 like this. That is what methylene is formed. Okay, I hope this is clear without any confusion. Okay, next, one more thing. So same thing, here carbonyl group is there now. So whenever we are treating carbonyl groups with zinc amalgam and HCl, we will be getting alkanes as a product. So this is what reaction taking place in acidic medium called as Clemmensen reduction. Now same kind of process conversion takes place. See, carbonyl groups converts into alkane, same like hydrogen I am writing, same as Wolff Kishner Clemmensen reduction only. So here we have Wolff Kishner reduction. In this we will be using hydrazine, NH2 will be used. Okay, so these hydrazine in basic medium, so this is in acidic medium, this is in basic medium, under heating condition gives alkane as a product. Hope that is also clear. Next, Itard's oxidation. Yes, that is also important here. So look here, whenever there is something like Itard's oxidation, here we will be using chromyl chloride, see CrO2 Cl2. So this will be the reagent used in the Itard's oxidation. Okay, now look, toluene, I am taking toluene means methyl benzene CH3. Okay, so this upon treating with CrO2 Cl2, so what we will get is we will be getting a benzaldehyde, like aldehydic product. Okay, so here I will be writing. So convert this into this form, what the alkyl group you convert into this form. So here during this process there is one intermediate, because this is asked in the previous exam. So what is the intermediate formed here? So just take this. Okay, here 3 hydrogens are there now, so place that one hydrogen as such and write remaining 2 hydrogens are getting oxidized. So Cr, O, Cr, Cl2, OH. So this will be twice. So just oxidize these 2 hydrogens by using 2 moles of this, and we will be getting this as a product. So this is the intermediate, this will be the product. Okay, I hope the process is clear. So what happens in the ETORS reaction? So methyl benzene or alkyl benzenes upon treating with chromyl chloride CrO2 Cl2, it gives benzaldehyde as a product, or like aromatic aldehydes as a product. So the intermediate is this one. Okay, I hope the thing is clear. Next, okay, so these are the things which till now I have discussed, those are very important. Along with that, just try to look here, Aldol condensation. So what happens in Aldol condensation and Cannizzaro reaction? Look here, these are also important. So next I will be discussing like this until until here I will be discussing all the 39 named reactions in a quick manner. After that, if we required, we will be discussing again Aldol condensation with clear cut mechanism if required. Okay, so it is better you just make short notes out of this lecture, that will be more helpful for you. Okay, see Aldol condensation, what happens here? So aldehydes, ketones, aldehydes are ketones with dilute base gives beta hydroxy aldehydes, which upon heating gives alpha beta unsaturated carbonyl compounds. It means, let us take one aldehyde. See, this is the aldehyde I am taking. So if this is a carbonyl carbon, so this carbon is alpha carbon, which is having alpha hydrogens. So whether you take aldehydes or ketone, that should contain alpha hydrogen. Okay, that alpha hydrogens containing carbonyl compound. Okay, upon treating with dilute base, dilute NaOH, KOH, BaOH twice like that, so it gives beta hydroxy carbonyl compounds. It means what exactly? See, during this process you should take this as 2 moles. Okay, now what happens here is, write 1 mole as it is. Okay, see, now I have written till here na 3 hydrogens are there na. Always remember, these alpha hydrogens of carbonyl group are acidic. Why they are acidic? Because if we are, I am saying acidic na, after removing one H plus ion, there will be negative charge on this carbon, right? So this negative charge will be stabilized by conjugation like this. So due to this reason, the alpha position carbon having hydrogens are more acidic. Whenever we are treating with base, that acidic hydrogen is removed and gives respective carbon anion like this. Okay, so this carbon anion, attacks on the 1 more mole. I mean, we are taking 2 moles now. 1 mole will form carbon ion, 1 mole carbonyl group remains as such. Okay, so this carbon anion will go and attack here and forms alpha beta hydroxy aldehyde. So what exactly beta hydroxy aldehyde? So just look here, just I will be giving direct product. Okay, so this is a negative part carbon, so this will be added to 1 more carbonyl group. So it means whenever it is added here, so this carbon oxygen will be converted into this form. Again it is having 1 hydrogen and the remaining part is this one. Like this you can write. I hope this is clear. So what we have taken, this aldehyde we have taken 2 moles, one is this one let us say, and 1 more mole also I am writing. Okay, 1 minute. So here I am taking 2 moles of this, means this is the 1 mole, and 1 more mole here I am writing as a negative charge. So these are the 2 parts. How I got this negative part? When we treat with the dilute base. So now add this negative charge on this carbon, because this is electron deficient, and forms hydroxy group like this. Okay, that is how we are getting beta hydroxy carbonyl compound. Okay, upon treating these or upon heating these, what happens? We have 1 more alpha hydrogen here now. So this alpha hydrogen and this OH both will be removed as water molecule, like H2O is removed, and we will be getting a product OH CH double bond CH CH3 like this. So this is alpha and beta. So I can say alpha beta unsaturated carbonyl compound. So this will be a product in the aldol condensation. Okay, so you should get identify what kind of reactions it is taking place. Okay, now here I have taken only one type of aldehyde, right? So if I take 2 type of aldehydes, for example, here I am taking acetaldehyde and acetophenol, both of them having alpha hydrogens, right? So in this case, what are the products formed here? So in the first case, only one type of alpha beta unsaturated product is formed, right? So now here we have 2 types of, different types of combinations. Let us say this is A compound, this is B. Upon aldol condensation, both of them having alpha hydrogens, right? Okay, so these alpha hydrogen containing carbonyl compounds, see, now this itself combine and form a product like AA type product, alpha beta unsaturated product of this molecule itself like AA type product, and this molecule itself as BB type product, right? And the next one cross product like AB, and one more cross product as BA. So how many products are formed here finally? So we are getting 4 products in these reactions. Okay, in this reaction. I hope this is clear without any confusion. Okay, the next thing is here we have Cannizzaro reaction. So what exactly Cannizzaro reaction? Let us see. Okay, so here carbonyl compounds without alpha hydrogens. It means, for example, I am taking formaldehyde here. Is there any alpha hydrogen? No. To this carbon there is no directly attached like methyl groups or something like that. So whenever we are treating with concentrated base, okay, gives like oxidized product like this and a reduced product like this, CH3OH. So this is carboxylic acid and alcohol are formed. So this is an example for disproportionation reaction. Look here, Cannizzaro reaction, what happens? Aldehydes with no alpha hydrogen gives alcohol and carboxylic acid are the products. Okay, so it means, so you should not get confused between aldol and Cannizzaro reaction, never. Okay, because here whenever we are saying aldol, so there we need at least one alpha hydrogen, right here. Okay, here, and for Cannizzaro reaction there is no requirement of like alpha hydrogens. If any alpha hydrogen is present, that will undergoes aldol condensation. If there is no alpha hydrogen, that will undergoes Cannizzaro reaction. I hope this is clear. Okay, then next HVZ or Hell-Hollard-Zelensky reaction. So what happens here? Carboxylic acid converts into alpha carboxylic acid. So just simple this is, look here. If we have like this, or let me take little more bigger one, this one I have. So whenever we are treating this with halogens, okay, see here what they have written. Carboxylic acid converts into alpha halo carboxylic acids. So this one whenever we are taking, this is the alpha position now. So there you just substitute one chlorine. This chlorine we are taking now, chlorine, POOH. So this is the final product in HVZ reaction. So you can remember this one also. Okay. So just whenever you hear the name of a particular reaction, you should get a strike of what happening in that reaction, what is the product, what is the reagent. That's it. That will be effective preparation. Okay. Then next, look into this. Friedel-Crafts alkylation acylation. So benzene with alkyl chloride AlCl3 gives alkylated product. It means for example here I am taking benzene. So these upon treating with RCl and anhydrous AlCl3, okay, like this they will be mentioning. So what we need to understand here is, this is a Lewis acid, here we have chlorine, therefore together they will be removed as AlCl3 we are taking now. So this together removed as AlCl4 and generating a carbocation here like this negative part. Okay, so this is a carbocation that should be added onto this benzene. Now this using these pi electrons which are acting as a nucleophile and taking this electrophilic carbocation. Okay, so now what happens from this? From these we will be getting, so just add it here R. Okay, here is the positive charge, this is a hydrogen. Okay, so now from this remove this H plus ion from here. Finally what is the product? R is a product. So benzene with RCl alkyl halide gives alkyl benzene, that will be the product. So this will be the mechanism which I have shown roughly. Okay, now tell me, without writing any mechanism, you just try to answer for these two reactions. This one, these are anhydrous AlCl3s only, and the third one is this one. So try to answer this question and write in the comment box. So I will be giving you some time to solve this. So just give a try. I will be taking some water. Okay, fine. Then next, look here. So what I told you, so just remove this whatever the halide attached to this alkyl group using this AlCl3 and attach the remaining alkyl group onto this benzene. So therefore our A will be what? So our A will be CH2 CH3, that's it. Then what about our B here? So remove this Cl, okay, attach the remaining part onto this benzene ring. Therefore, CO CH3. Here we have alkylated this benzene, so we should say Friedel-Crafts alkylation. The first reaction is Friedel-Crafts alkylation. See, we have added this acyl group onto this benzene ring, therefore acylation reaction, Friedel-Crafts acylation reaction. So our B is Friedel-Crafts acylation. So again, fourth one, see here, this is also alkylation, because using this AlCl3, if we remove this chlorine, so we will be getting a carbocation like this. This one is a carbocation, but we know this is primary carbocation, okay, which is the least stable. By rearranging this carbocation, by shifting this hydrogen from here to here, carbocation rearrangement takes place, okay. So here we will be having a positive charge, okay. This is tertiary carbocation, okay, which is more stable. This tertiary is more stable. This is happened by carbocation rearrangement. So in alkylation, always remember, if less stable carbocation is formed, that will be rearranged to more stable carbocation, and this will be involving in the reaction with this particular benzene. So alkylation takes place like this, alkyl group will be, now this is a carbon which is attached to the benzene. So 1, 2, 3, so this will be the product. I hope C is also clear, right? I hope this is very, very clear. So now I will be giving one question as a homework, so just tell me. So I am giving this one. So this is the primary alkyl halide using anhydrous AlCl3. When we treat this with benzene, so what is our product D here? So write in the comment box if you are clear with this C, like answer for C, you can easily answer what is exact answer for this particular D. Okay, write in the comment box, I will be waiting for that. Next, from amines, diazonium chemist. Okay, it means diazotation, already we have seen. Aniline upon treating with NaNO2 or HNO2 upon heating gives diazonium chloride, right? So that is what the diazotation reaction. See, primary aromatic amines. Okay, so aniline is primary aromatic amine only, na? Okay, so R, like nitrogen should be attached only with one carbon, then we can say that is primary amine. Okay, so whenever we are treating this with HNO2 or NaNO2 in acidic medium, so gives Rn2 plus and Cl minus. So in presence of some HCl, some acid reagent if we take, so this will be the diazonium chloride salt. Okay, now this diazonium chloride upon treating with phenol or aniline, so it will give azo compound. It means, look here, I am taking this is a diazonium chloride. Okay, so this one upon treating with phenol, okay, we know phenol will be electron releasing group and increases electron in state ortho and para position. Na? So since this is bulky group, so we cannot add it the ortho position because it will be added but the product will be minor. But if the reaction taking place at para, that will be major because of less steric repulsion between this incoming group and this OH group. Okay, therefore reaction product formed at para will be major. So what is the product formed here? Okay, what is the product formed here? So OH here, and here this side N double bond N, this will be the product. So this is called as azo compound. Okay, so this is the azo compound, you should remember. Okay, then next here is Hoffmann bromamide reaction. Similarly, same story applicable for aniline also. Instead of taking phenol, we will also get, instead of here OH, we will be having phenol, like OH we will be having NH2. So in case of aniline, so those are dyes, like coloring agents are there now. So those are dyes. Okay, like orange color dye, will be seeing those kind of product. Okay, the next Hoffmann bromamide, one of the very, very important reaction. See, simple it is, amides are there na, RCONH2, this is the amides. Okay, so these amides, when we are treating with like Br2 in presence of basic medium NaOH, so whenever we will be seeing like this, so just remove this carbonyl group from here, that will be the product. So what we are getting finally, RNH2, that's it. So this is what happens in the Hoffmann bromamide reaction. See guys, this Hoffmann bromamide reaction, they will include definitely somewhere in the given question paper, but we need to identify whether what kind of reaction is taking place in that particular process. Okay, so majorly they will be saying like A gives rise to B, B is giving C, and C will be giving something like D. So for conversion of this, what is the reagent is for used, so what is the product used here by giving the reagent here, something like that will ask. So we need to identify individual reactions which are happening in this process. Okay, so now once after completing this session, in the next upcoming sessions, one day I will be planning about this chain reactions. I mean A gives B, B gives C, these conversions are there now. Based on these Nemer reactions, we will be discussing about those conversions. Okay, so just try to learn this, make the short notes as much as you can. Next, Gabriel phthalimide synthesis. So here we have something called phthalimide like this. Phthalimide means this one is a phthalimide. Okay, so whenever we are treating this with base, here we have acidic hydrogen that will be taken by this base and results to form potassium phthalimide. It means this will be the potassium phthalimide. Just acid H plus is giving this base, taking that H plus, remaining part is this one. This is what? Potassium phthalimide. Now this potassium phthalimide, whenever we are treating with any alkyl halides, like any means it should be aliphatic, okay, like this, okay, RX, like methyl chloride, like that. Okay, so now this negative part will be added on this carbon and halogen goes out via substitution, nucleophilic substitution reaction, and gives the product as like this. Okay, so upon hydrolysis, upon adding water, hydrolysis, break this side bond, and just write R NH2, the remaining will be carboxylic acid. Like this. So you should not get scared of looking at all these steps. So just remember what happens whenever you are seeing phthalimide, like phthalimide will be either having structure like this or they may directly give like this. You should not get scared by looking at the structure. So whenever giving the phthalimide structure, okay, and alkyl halide, so you just remove that halide, take the R group as such, alkyl group like that only, and to that you add NH2, that's it. This will be your final product. Okay, so for example here if I give methyl halide, so methyl amine is a product, ethyl halide, ethyl amine is a product, like that. Primary amines are you prepared in this reaction. I hope this is clear. Okay, next, so these primary amines, now how can we test? So here we have, again this is also very important. All the three reactions are very important, these three reactions again. So Gabriel phthalimide is done, carbyl amine test. So whenever we have primary amines, again this is for only primary amines, upon treating with chloroform CHCl3, so this will be forming isocyanides like this, RNC. So these are having foul smell, so by looking at the smell will feel very foully smell, very unpleasant to take the smell. Okay, so that indicates it is a primary amine. Okay, so carbyl amine test will works only for primary amines. So what is the reagent? Chloroform will be used in the basic medium. Okay, so here which are the following gives carbyl amine test? So try to answer this. Carbyl amine test. Okay. So what is the basic condition I told you? That should be primary amine, that's it. Yes, identify which of the following gives carbyl amine test. Look here, this nitrogen is having only one carbon attached to it, therefore I can say this is primary amine, so it will be giving carbylamine test. Okay, this is again attached only with the one carbon. See, nitrogen directly surrounded by one carbon only, there is no other side carbons, right, to the nitrogen, therefore this is also primary, gives carbylamine test. Next, here this nitrogen is connected with the two other carbons, so I can say this is secondary carbon, secondary amine, so secondary amine, so it won't give, only primary amines. See, this nitrogen, see whatever the big, how much big the alkyl group, no matter it is. So if this amine is primary, then that will be giving carbylamine test. So A, B, D are the answers for this particular question. Okay, hope this is clear. Next, alcohols. Okay, so alcohols, what is the test here we will be using? See, alcohols, we have these alcohols can be primary, secondary, tertiary, right? Okay, so we will be taking Lucas test. So here concentrated HCl and ZnCl2. So this is called as Lucas test, okay, or Lucas reagent. Okay, so now whenever we have this primary, secondary, tertiary alcohols, upon treating with this, that will be giving alkyl chloride as a product. Okay, here ZnCl2 HCl is used now, so alkyl chloride is a product form. Out of these three alcohols, tertiary alcohol react faster, then secondary, then primary. So tertiary alcohol will form the product within some 2 or 3 seconds, like a turbidity, white turbidity will be seen. So that will be resulting, but that will be saying that product is formed, and it will be taking some minutes, and this primary will be very slower. So tertiary more reactive. This is also very important point. Okay. Next, Williamson ether synthesis. So this follows again SN2 mechanism. So what is the thing here? They have taken alkyl halide. So alkyl halide with alkoxide ion. So let us say ethoxide ion I am taking. Okay. So this happens in acetone polar aprotic solvent like acetone, like that, because I told you this mechanism is SN2. So just remove this halogen, from backside you add this alkoxide group, and we will be getting ETOR. Ether is a product. Okay, important reaction for preparation of ethers. Then next, Victor-Mayer test. So Victor-Mayer test, it means these alcohols. So again, so this can be used for identification of alcohols. So primary test for primary, secondary, tertiary alcohols. So here we can also say RBW test. Okay, so tertiary, see here this is what RBW test, also called as Victor-Mayer test for identification of alcohols. You can remember that. Next, miscellaneous important points here. Tollens test is for what? Again we will be saying it as silver mirror test. So what happens here? Aldehydes, all type of aldehydes, aliphatic, aromatic, whenever we are treating with AgNO3 and ammonium hydroxide. So this will be ammonical silver nitrate test, we can also say. Okay, so that will be giving a silver mirror, that is indication for aldehyde. So how it is forming this aldehyde, whatever aldehyde is there now, so that when it is treated with this ammonical silver nitrate solution, forms are COO minus and Ag. So this Ag is the reason for this silver mirror appearance. Okay, so this is how we can identify. So during this process what happened? Aldehyde is oxidized to carboxylic acid. Similarly, for Fehling's reagent also test also takes place. Okay, here we will be using Ce2Cl2. Okay, so aldehyde convert into carboxylic acid, same like this, but here it is having red color due to presence of copper. Okay, now here this will be only aliphatic aldehyde. Fehling's test is given only by aliphatic aldehydes, not by aromatic. Okay, only aliphatic aldehydes. Okay, next, both won't show reaction for ketones, and they will be showing reaction for alpha hydroxycarbonyl compounds. It means for carbohydrates. Okay, whether it may be ketone or aldehyde functional group, if it is having alpha hydroxy group, then that will be showing Tollens test and Fehling's test. You can remember that. And then next, they will also react with terminal alkynes, because alkyne hydrogen is acidic now, therefore that hydrogen will react and gives Tollens test positive test towards toluenes and phenolines. Okay. Next, iodoform test. What happens in iodoform test? So iodoform test, whenever we are seeing methyl group containing ketones, aldehydes, okay, whatever the group here, if it is containing methyl group at one side, aldehyde or ketone, no issues. Okay. When we are treating this with methyl group containing ketone or ethanol, so when we are treating this with base NaOH, okay, in presence of base with halogens like Cl2. So what happens is here three hydrogens are there now. So let us say 3 hydrogens are there, right? 3 hydrogens. So now what happens is 3 chlorines. So just remove this hydrogen, again remove this one, remove this chlorine. So what is the remaining part? Here we have CO, Cl, Cl, Cl. Like this we will be getting trihalocarbonyl group will be obtained here. So this again further treating with this base NaOH, so it will be giving carboxylic acid, okay, like this, O minus. So what happens here, we will be getting this comes out, okay. So if it is coming out, it will be CCl3, 3 chlorines are there, CCl3 minus, if you give one proton, it will become chloroform. So if here we are taking chlorine, we are getting chloroform, bromine, bromoform, iodine, iodoform. So whenever we have methyl group containing ketones or aldehydes, upon treating with chlorine halogens in basic medium, gives chloroform, haloform test, okay. Now not only methyl group containing ketones, but also ethanol, like primary alcohol it is, right. So let us see here, let me take this primary alcohol, this is a primary alcohol. So here NaOH Cl2 we are taking now. So this can also act as oxidizing agent and oxidizes this primary alcohol to respect to aldehyde, okay. So if this is the aldehyde, see here we have methyl group containing carbonyl group, right. So that's why it is also giving. So methyl group containing carbonyl compounds and ethanol will show haloform test, okay. Next, next Shorten-Bowman reaction. So acid chlorides with amine forms amides, okay. So it means, look here, I will be explaining this here. Acid chlorides I am taking RCOCl, okay, RCOCl with aniline, let us say NH2, okay. So now it will be just remove hydrogen from here and chlorine from here and attach the remaining part, CO, NH, CO, R. So this is what amide, right. So this will be the product formed in the Shorten-Bowman reaction, okay. Again next, Rosenman reduction. So here again acid chlorides you can take, again acid chlorides RCOCl, okay. Acid chlorides upon treating with Lindlar's catalyst H2PD BaSO4, okay. So what happens here is just remove this chlorine, so we will be getting replaced with hydrogen, aldehydes is obtained. So acid chlorides converts into aldehydes, so using Lindlar's catalyst. So this is Rosenman reduction. So in Stephens reduction what happens? So in Stephens reduction, so alkyl cyanides like RCN, alkyl cyanides, nitriles also we can say, upon treating with acid and SnCl2. So what we will be getting, this will be converts into aldehyde again, okay. So this is what Stephens, this is Rosenman reduction. Rosenman reduction is important again. So acid halides upon treating with Lindlar's catalyst gives aldehydes. Next here Woods reaction and Woods fatigue reaction you can remember. See, Woods reaction means alkyl halides, okay. Woods reaction, see alkyl halides with sodium in dry ether gives like coupling reaction. If you take 2 moles of this alkyl halide gives RR, which is a coupling product. If we take methyl chloride, we will getting ethane as a product. Okay, Wurtz-Fittig means, again listen here what exactly Fittig reaction first. If we are taking alkyl halides with sodium diether, we are saying Wurtz reaction, right? If we take aryl halides, 2 moles, okay, now here the remaining part is same, sodium in dry ether, so gives diphenyls, biphenyls are the product. So this is called Fittig, this is Fittig reaction, this is Wurtz reaction. Okay, if we are combining these two reactions, we can say Wurtz-Fittig reaction. So it means Rx plus alkyl halide, aryl halide, sodium dry ether, sodium in dry ether if we take. So remove these 2 halogens and write the remaining part, that's it. Remaining part is this one, that will be the product. Alkyl benzene is a product. Hope it is also clear. Next, HVZ reaction already we discussed. Okay, carboxylic acid with halogen in red phosphorus gives alpha halo carboxylic acid. Okay, so these are the few important Nemer reactions which must focus by every student. Okay, Perkins reaction also important. See, aldehyde with an acid anhydride base gives alpha beta unsaturated acids, something like cinnamic acid is formed. Okay, so these are the reactions you should focus more. Okay, all these reactions are important, all these 39 reactions are important. I hope this session is really helpful for you. And remaining things, see, I need to discuss other like already discussed Aldol Condensation, everything. So in the next class, see this short, whatever in the short duration we have seen all the 39 Nemer reactions in this session. Okay, so in the next session, first of all I will discuss based on the discussion, based on our discussion till now, whatever we did, on that I will be solving the questions in the upcoming session. And in other sessions, in the upcoming sessions, I will be discussing all the Nemer reactions very clearly by taking one reaction, like important Nemer reaction specifically, and discussing clearly in detail about that in the upcoming sessions. Okay, so this is about the session. If you really like the content, please click on the like button and share with your friends. Thank you.